Did everybody get one of these? Each. Okay. The library ran out of blue paper, so some of your workbooks are white. Sorry. So yesterday we talked about simplifying radicals. So if you are simplifying radicals, you want to combine like terms first. So I want to combine like these. They're called coefficients because they're in front. And then I'm going to combine the other like terms, which are these, right? And I'm going to do that with multiplication since there's a dot in the middle. And so I'll do 8 times negative 8. That's negative 64. And then root, because the purple terms both have roots, and 2 times 2 is 4. All right? And then the square root of 4 is just 2. So this becomes negative 64 times 2. Or negative 120. Pretty straightforward, just combining the like terms. Anybody have questions on that? All right, yesterday we talked about, or maybe learned for the first time, I'm not sure, that number 2 is called conjugates. Conjugates are 2 binomials that have the same numbers in them. Like the actual number themselves are the same, but the second term in the binomial is one's a plus and one's a minus. It kind of is like differences of perfect squares, x plus 2, x minus 2. Those are conjugates. So the factors of differences of perfect squares are called conjugates. When you multiply conjugates, the middle term cancels out. So if I were to do this one using FOILing method, right, I would do 8 times 8, which is 64. 8 times negative root 2 is negative 8 root 2. I'm just kind of putting those two things together, and positive and a negative makes a negative. 2 and 8, they're both positive, so positive 8 root 2. And then root 2 times root 2 is root 4. I'm just going to move these over. So we've got 64 minus 8 root 2 plus 8 root 2. And then root 2 times negative root 2 is minus the positive times the negative root 4. And what happens here is when we FOIL this out, we end up with a minus 8 and a plus 8, and those cancel out. Conjugates, when you have something like this, the middle term will always become 0. So then from here, this becomes 64 minus root 4, but that's minus 2, because the square root of 4 is just 2. And so the answer to this is just 62. You're doing FOIL, and so even without knowing what a conjugate was, you should be able to FOIL that out and end up there at 62. All right, for the next one, we talked about yesterday how if you have a root in the bottom, your problem's not done. You have to do this thing called rationalizing the denominator. So to rationalize this denominator, to rationalize any denominator, you multiply the bottom by itself. Right? So whatever root is in the bottom is what I'm multiplying by. And if I multiply the bottom by that, I have to do the top as well. So if the bottom was a square root of 6, I would multiply the top and bottom by square root of 6. If the bottom was a square root of 20, I'd multiply the top and bottom by square root of 20. So I'm multiplying by whatever is in the bottom. So then I'm going to go straight across. It's 4, and then root 3 times root 12 is root 36. 3 times 12 is 36, so root 3 times root 12 is root 36. And root 12 times root 12 is root 144, right, which is a perfect square. So this problem becomes 4 times 6 over 12. 36 is a 6, 144 is a 12, or 24 over 12, or 2. Okay, that one? All right, and then finally, if I want to rationalize this one, the only way to get rid of a root that has an addition symbol in the middle is to use the conjugate. So we're gonna do something like we did here. The only way to cancel out that root 2 is to multiply by its conjugate. If it was just root 2 by itself, I could multiply the top and bottom by root 2. But it's not just root 2 by itself, it's got this other piece. So I'm gonna multiply by its conjugate. Conjugates have the same numbers in them. So I'm gonna use the 2 and I'm gonna use the root 2. Conjugates just have opposite symbols in the middle. So this has a plus, so the conjugate has a minus. And if I do that to the bottom, I just have to make sure that I do the same thing to the top. And now I'm going to distribute. So it's 3 times 2. 3 times negative root 2 looks like this. And then on the bottom, it's 2 times 2. 2 times negative root 2. Root 2 times positive 2. Positive root 2 times negative root 2 is negative root 4. I'm just multiplying each thing.
Did you just put the denominator on both of the sides and multiply it?
I put the conjugate of the denominator
Okay.
on the top and bottom. We were focusing in on the denominator as your first step, and then whatever you do to the denominator, you have to do the top too. So that's why I did that to the top. Now from here, I can't do anything with the numerator. There's no like terms there. But in the denominator, I've got a negative 2 root 2 and a positive 2 root 2. Anytime you multiply by the conjugate, the middle term zeroes out, just like it did here. And I end up with 4 minus the square root of 4, which is 2. So 6 minus 3 root 2 all over 2 is the final answer. The denominator is a rational number, meaning the denominator is a whole number. That's the goal when you rationalize the denominator. We got that root out of the bottom. That's what we did all class yesterday. So if you weren't here, that's a quick summary of it. I'll try to keep throwing them up as warm-ups to like refresh your memory for that stuff. I think that you'll find that today is much easier than yesterday because we're just going to do Pythagorean theorem, which I feel like we know like the back of our hand. And then special right triangles, which is just memorizing. Like if you can memorize 2 rules, then you can do special right triangles. So we're going to do those today. And then tomorrow we'll practice this stuff and then the triangle. So nothing new, just review of that stuff. And then we'll do some SOHCAHTOA next week, right? So in your toolkit, which is the other packet, the one we just weren't in, this is on page 2. So we're gonna do the box part together as our class examples, and you're gonna do the bottom part as your practice. All right, so this is Pythagorean theorem. We can use Pythagorean theorem if and only if you are looking at a right triangle. Okay, if it's not a right triangle, the rule doesn't work. Okay, in Pythagorean theorem, a squared plus b squared equals c squared. C is the hypotenuse. How do you know which one's the hypotenuse? Opposite of the right angle. Okay, so you got to find the box and then go opposite of that. That's your hypotenuse. So in this example here, here's my box. Opposite of that, this is my C. It doesn't matter which one you pick for A and B. C is the one that matters. So opposite of that 90-degree angle box. So if I wanted to solve for x here, I would do a squared plus b squared equals c squared. Or in this case, that's x. So I'll put x. All right, and then we're going to do 2 squared, 6 squared equals x squared. Well, 4 plus 36, where can I do this? I'll go up here, is 40. And if I want to get rid of the squared, I'll take the square root. And then yesterday, if you were here, we talked about simplifying roots. So I would check to see if that's a perfect square, which it's not, which you probably already know that, but the square root of 40 is not a perfect root. And if it's not a perfect root, you want to simplify it if possible. So you can go to your y equals screen and do that number, which in this case is 40, divided by x. And what you're looking for in this list is a perfect square. So like 40 isn't a perfect square, 20 isn't a perfect square, 10 isn't a perfect square, 8 isn't a perfect square, 5 is not, but 4 is. So we'll use 4 and 10 when we simplify this root. Root 4, root 10, or 2 root 10 is that missing side line. So you want to have it in simplest radical form. You're not writing that as a decimal. So we'll keep it as a root and we'll simplify it when possible. For the next example, I'm finding the 90-degree angle. I'm looking across from it. So my hypotenuse, my C, is 6 here. So these triangles look similar. They have the same numbers, but x is not going to be the same because the hypotenuse is in different positions. So I'll do x squared plus 2 squared equals 6 squared, making sure that the hypotenuse is on this side of the equation. So x squared plus 4 equals 36. Subtract 4. So x would equal the square root of 32. But that's divisible by 4. Actually 16, right? My board froze. I'm going to do root 16 and root 2. So x is equal to 4 root 2 here. You guys remember Pythagorean theorem? I feel like we were just doing it in the last unit. But in the last unit, a lot of the times we took these roots and we just made them decimals because we were graphing. We're not graphing here, so you're going to keep them as radical form. All right, so for your practice, I'm going to have you do the 4 at the bottom of the toolkit here. Just make sure your answer is in simplest radical form, so you need roots. You think 8, 2, 4, 6, 8 minutes? That might be more than you need, but we'll go with that. It doesn't matter. A and B doesn't matter. C is what matters. So you can switch them. Good for him.
And then the one day Mr. Perez got on the bus, he was swearing his words. Thank God. Every Monday he's in
Anybody need more time? I'm trying to keep pushing forward so we should be done, right? That's the goal. Get it over with. Alright, so, first one, hypotenuse is 10. You gotta make sure the 10's on the other side of the equation. Besides that, order doesn't matter. I end up with 8. You okay with that one? Yeah. Alright. Next one, hypotenuse is 4. So where the other stuff is doesn't matter. Make sure the 4 is on the other side of the equation. I end up with square root of 14, which doesn't reduce. There's no perfect square factors of 14. Next one, hypotenuse is 18. So just make sure the 18 is on the other side. Now for this one, I end up with root 275. That does reduce, right? 275 is divisible by 25, which is a perfect square. So I had to split that one up. So the answer is not root 275, it's 5 root 11. If it can simplify, you should simplify it. Last one, hypotenuse is x. So it doesn't really matter what a and b are, x needs to be on the other side of the equation. And 130 actually doesn't simplify, it doesn't have any perfect square factors. So it just stays as is. Pythagorean theorem in only one. You okay with that? Alright, I think you learned special right triangles in like your sophomore year maybe. But this is on page 3. So 2 special right triangles that you have to memorize. It really is just memorization. Alright, so there's the 45, 45, 90, and there's the 30, 60, 90. So all of the ones are, we're going to start with the 45, 45, 90 one. Alright, so how do you know it's a 45, 45, 90? Well, either it says 45 and has a right angle, or you might see something like this. If you have 2 sides of a triangle that are the same, then you have to have 2 angles that are the same too. So if you see like markings like that, that could mean 45, 45, 90 as well, and you might not see the angle itself. Alright, so 2 side lengths are the same, you're looking at a 45, 45, 90, or you've got the markings. So if the 2 angles are the same, then the 2 sides are the same too. So across from the 45s are the same thing. You can see that they are x and x, right? So across from the 45 are the same, and then the hypotenuse is whatever the side lengths are, root 2. So here's what you need to remember. X root 2. Okay? X root 2. Two sides are the same. The other side is whatever that side length is times root 2. So in our example here, across from the 90-degree angle is the x root 2 side. Right? So across from the 90-degree angle is your x root 2. And then the other two sides are your x. Right? So x root 2. X root 2 is across from the 90-degree angle. So what that tells me about my image is that the x value is 5, right? Because I don't know what either of these are, but x is equal to 5. You with me so far? So if this x equals 5, well then this x has to equal 5 too, right? If this side's 5, this side's 5. That means that the a value is 5. You okay with that? This side is the same as this side. So if this side is 5, this side is 5. And the hypotenuse is the side length times root 2. So if the side length is 5, then the hypotenuse is 5 times root 2. So B is 5 root 2. This is another 45, 45, 90. It doesn't have like the tick marks, but it's got a 45 and a 90, so this has to be 45 too. The three angles inside of a triangle have to equal 180. That's the only combination that works. So across from the 90-degree angle is your x root 2. And then the side lengths are your x's. X root 2. Across from the 90 is your x root 2. So what I know is that my side length, my x value is 2 root 2. So here's another x. That must mean that this is 2 root 2 as well. This side length has to be the same as this one. So B is 2 root 2. Everybody okay so far? A is a little bit less straightforward too. A little bit less. A is less straightforward, okay? So A is the side lengths times root 2. I know that the side lengths are 2 root 2, and now I have to multiply that by root 2, right? It's x times root 2. X in this case is 2 root 2. So I'm doing 2 root 2 times 2. So it becomes 2 root 4. 2 times 2 is 4, or 2. So A is 4. X root 2. Alright, so find your right angle. Across from it is x root 2. So the 20 is in the x root 2 spot. So I can solve for the side lengths, which are x, by solving this equation. 20 is equal to the x root 2 spot, because it's across from the 90-degree angle. How do I solve that? Divide by root 2. I'm just going to bring this down here. So x is equal to 20 divided by root 2. But yesterday we learned that you can't have a root in the bottom. So what do I need to multiply by? Alright, so we're going to multiply by root 2 over root 2. So I have 20 root 2 over root 2 times root 2, which is root 4, which is 2. 10 root 2. So if the hypotenuse is 20, the hypotenuse is in the x root 2 spot, that must mean x had to be 10 root 2. So the side lengths both have to be 10 root 2. All you have to do is look across from the 90-degree angle and set whatever's across from the 90-degree angle equal to x root 2. If you have a side length, then you don't really have to do any work. right? If you have one at the sides, you're just multiplying it by root 2 or keeping it the same, all right? So 45, 45, 90, x, root 2. So you are going to try 4 through 6. They are all 45, 45, 90, using what you know to solve for a and b, or x and y. Gotta look across from the 90-degree angle. So if across from the 90-degree angle for number 4 is x root 2, but it's actually 8 root 2, then what's x? Okay, got them lined up. 8, right? I don't even have to solve for it. Look, I already have the root 2, I just don't have the number in front. So x is 8, meaning the side lengths are 8. That means this is 8 and this is 8. It's x root 2. So 8, 8, 8 root 2 completes the triangle. These are both 8. This one's not as straightforward though because the hypotenuse doesn't have a root 2 in it. So now we have to do some work to solve for the side length. So I would divide by root 2. So x equals 12 over root 2. And I would rationalize it. So I get 12 root 2 over root 2 times root 2, which is root 4, which is just 2. And then 12 divided by 2 is 6. So the side lengths, x, are 6 root 2. And then for this one, I actually have the side length. So if I have one side length, I immediately have the other. So the y's got to be the same as the 3 root 2. And then the hypotenuse is whatever the side length is times root 2. So the hypotenuse is 3 root 2 times root 2, right? Side length times root 2. Or 3 root 4. Or 3 times 2. So the hypotenuse would have to be 6 for this one. Just a matter of memorizing the rule. Side lengths are the same, hypotenuse is the side length times root 2. Sometimes you have to manipulate it a little bit to make it work the way you want it to. Alright, so 45, 45, 90. We'll practice this one tomorrow. 30, 60, 90. You'll know it's a 30, 60, 90 if you have a 90-degree angle and a 30-degree angle, or a 90-degree angle and a 60-degree angle. Right? You might not see them all, but if you have 2 of the 3, then you can figure out what the other one is. So if I have a 90 here and a 30 here, by default that's 60. If I have a 90 here and a 60 here, by default, that's 30. I have a 90 here and a 60 here, by default, that's 30. Alright, so 30, 60, 90 has different rules. The angles are different, so you're not going to have like x, x, x root 2. All of the side lengths of this triangle are going to be different, okay? So you'll start with your basis. Your basis is your 30-degree angle side. So opposite of your 30-degree angle is your smallest side length. We'll call that x. Your hypotenuse is always double your smallest side length. So if your smallest side length is x, then your hypotenuse is 2x. All right, so your smallest side times 2 is your hypotenuse, and then your 60-degree angle side is your smallest side times root 3. So it's x root 3. So in this case, this is x, this is 2x, and this is x root 3. Alright, so you're finding your smallest side, that's your x, your hypotenuse is 2 times that side, and then your 60-degree side is x root 3. So looking at that picture after filling that in, here's what I know. X is 2. Because next to that part I labeled x is the number 2. So if x is 2, well then 2x is 2 times 2. So this side length up here is 4. And if x is 2 and this side length is x root 3, then this side length is 2 root 3. Alright, so you just have to memorize the rule, and once you memorize the rule, you just apply it to the numbers you're given. So, I find the 30-degree angle, and opposite from that, I'm going to label it x. I find the hypotenuse, and opposite from that, I'm going to label it 2x. And I find the 60-degree angle, and opposite from that, I'm going to label it x root 3. The key here is to figure out what x is. If you can figure out what x is, you can work your way around the whole shape, right? So here's what I know. 16 is in the 2x spot. So I could do 16 is in the 2x spot. So if 16 is in the 2x spot, what's x? 2 times what is 16? 8, right? We can solve this by dividing by 2. So this tells me that x is 8. So the y side length is 8. And if x is 8, then x root 3 is 8 root 3. So this side length is 8 root 3. Across from the 30-degree angle is x. The hypotenuse is 2x. And across from the 60-degree angle is x root 3. So look at what we've got. We've got the across from the 60. 5 root 3 is in the x root 3 spot. So what's x? 5. Right? Because I already have the root 3 part taken care of, which means the x must be 5. So 2x must be 10, right? Because 2 times 5 is 10. So x, that spot is 10, and y, that spot is 5. Alright, last 3. You guys just do these. As you do them on your paper, I'm just going to fill in the answers up here. Alright, so these are all 30, 60, 90.